I don't know if anyone's told you, but I'm proud of where you are right now. To still be living here and continuing on no matter what mental challenges have approached. You are still here.
Okay, wow, jumping from limits into derivatives, it's quite a jump, honestly. However, I promise you that we are going to go through this together. For you guys in Calc AB or BC, we are going to get that 5. Well, to start with our lesson, do you remember rate of change? The change in y over a change in x? Well, we know that the average rate of change represents two changing quantities in a relationship and how it's represented by a secant line in a function. Well, what about finding that instantaneous rate of change? How do we do that? Well, essentially, it's all about the derivatives, which can represent a tangent line on a function, as it's representative of the rate of change at a certain point. Now, how do we even format what derivatives are? Well, if we only have a limit of h approaching 0, and have the function look like this, we can effectively calculate what our derivative will look like. We can also have our derivative look like this function right here. For our example function, let's find the instantaneous rate of f of x is equal to x squared minus 4x. To start, for each x within the original function, we will insert our x plus h, as seen with our limit here. At the end, we will then subtract the original function from our new function based on the x and h. Now, hopefully, with you knowing how to FOIL correctly, we can cancel out many polynomials here, like x squared and 4x. Once you're done, you'll have a function with all h's here. And then from here, you can factor out an h from the numerator and cancel out with the denominator from there. This should leave you with the clean function to directly substitute in 0, and you can get an answer of 2x minus 4. That will be our instantaneous rate of change, or the derivative. Next, I think we should talk about the differentiability of the functions we have, and how it works. To start, your graph must contain local linearity and continuity for this to work. The function has to be smooth or curvy for this differentiability to exist. Cases in which differentiability fails are as follows. You have discontinuities in your function, vertical tangents, cusp, or even sharp turns. They all fail to exist as they either fail the local linearity test as seen with discontinuities, cusps, and sharp turns, or they're just straight up undefined as seen with the vertical tangents.